Welcome to Advanced Composites. Today is the third day of the sixth week of this course. Yesterday we solved a part of the semi-infinite problem, in the sense that what we have done till so far is that we have solved and integrated the partial differential equations. The solutions which emanate by integrating these partial differential equations are valid for all the four cases A, B, C and D, and then we implemented the fact that the laminate is symmetric as well as cross ply, and that led to the development of the solution as shown in this slide. So, we have now relations for u, v and w, and also relations for nx, ny, nxy, mx, my and mxy. And in these equations there are 8 integration constants C1 to C8, and now it is up to us to figure out the values of these integration constants by implementing the boundary conditions for cases A and B separately. So, now we will start implementing the boundary conditions. So, case A. So, what is case A? Let us look at. So, it is a pinned, fixed pinned and roller pinned situation. So, this is my x, this is the y direction, and the boundary conditions are u equals v equals w equals mx equals 0 at the negative end, and at this end we have nx is equal to nxy is equal to w equals mx. At the positive end this is equal to 0. So, first we know that nx equals C1, but at x is equal to a over 2. So, this is the length of the plate is a. So, at x is equal to a over 2, nx plus equals 0, which means C1 equals 0. Okay. Then we have nxy equals C2, and we also know that, but at x equals a over 2, nxy plus equals 0. So, this gives us C2 is equal to 0, and also we see that ny is equal to a12 divided by a11 into C1, and C1 is 0. So, because of that ny is equal to 0. Okay. And finally, we have mx is equal to 0. No, mx, the relation is minus qx square over 2 plus C3x plus C4. C3x plus C4. Now, we know that but mx is equal to 0 at x is equal to plus minus a by 2. It is 0 at both ends, right. This is the boundary condition. Mx is 0 at both ends, at this end and at this end mx is 0. So, we put that thing. So, we first put for the case at plus a by 2. So, it is equal to q a square over 8 minus plus C3 A over 2 plus C4. So, this is the condition at when x is equal to A over 2. And when x is equal to negative A over 2, then I still get q A square over 8 minus C3 A over 2 plus C4. So, this is when A is equal to minus A over 2. So, if I add these up, if I add these two equations, what I get is that C4 is equal to q A square by 8. If I add these up, and if I subtract these equations from other, when I subtract these equations from each other, I get C3 equals 0. So, that way I have solved for C3 and C4. So, essentially what I get is mx is equal to minus q x square by 2 plus q A square by 8. Or I can also express it in some another form, q A square over 2, I take it out, q A square over 2 I take out, and I get 1 over 4 minus x over A square. Okay. So, mx is equal to q A square over 2 1 over 4 minus x over A whole square. So, that is mx, and my is equal to d12 over d11 times mx. So, I can write it as my equals d12 over d11 q A square over 2 1 by 4 minus x over A square. So, this is my another relation. Okay. And then of course, m x y. So, this is m y, m x y is 0. So, what we have done till so far, figure out n x is 0, n y is 0, n x y is 0. I mean, this gives us n x is equal to 0, n y equals 0 and n x y equals 0. And m x is not 0, it is q A square over 2 times 1/4 minus x over A whole square, and m y is nothing but m x times d12 over d11, and m x y is 0. The other thing we have also found is, so now let us look at, so we have now figured out the values of n x, n y, n x y, m y, m x and m x y, but we have not yet calculated the values of u v and w, u naught, v naught, mid plane displacements. So, let us look at this. U naught x is equal to C1x plus C5 times 1 over A11, but we have already found that C1 is 0. So, is equal to, so it is C5 over A11, and now we implement the other boundary condition, but which is u naught at x is equal to minus a by 2 is 0. So, C5 is 0. V naught x, what is V naught x? It is equal to C2 x plus C6. into 1 over A66 into 1 over A66, and we have already seen that C2 is 0. So, this is equal to C6 over A66 it is equal to C6 over A66, and we have seen but V naught x at x is equal to minus a by 2 is equal to 0. So, C6 is also 0. So, C6 is 0. So, what these things give us is u naught x equals 0 and V naught x equals 0. And the last thing is about W naught. So, W naught x, and the relation for W naught x we have already developed is 1 over D11 Qx4 by 24 plus C3x cube by 6 plus C4x square over 2 plus C7x plus C8. Now, we have already said C3 is equal to 0 from here, and C4 is QA square over 8, right. So, we first use those conditions. So, this is 0 and C4 is QA square over 8. So, we rewrite it after making these substitutions. So, we get Qx4 over 24 plus QA square over 16 times x square plus C7x plus C8. Okay. And now we know that W naught x is equal to 0 at x is equal to plus minus a over 2 from the boundary conditions. Those are the only two boundary conditions which have not been implemented yet. So, if that is the case, so let us write down. So, if we implement the first boundary condition at x is equal to plus a by 2, we get this is equal to, and I can drop D11 because the left side is 0. So, I get Q A4 over 24 times 16. So, that is 384. Instead of x, I am putting a by 2. So, I get QA4 over 384 plus QA4 over 16 times 4, 64 plus C7 a over 2 plus C8. So, this is the condition when x is equal to plus a over 2.
I am confused, sir. I think there should be minus sign in Qx4 by 24. Qx4 by
Yeah, you are right. Here. So, it should be here also, yes. And the other boundary condition is that W is 0 at x is equal to negative a over 2. So, this is equal to minus Q A4 over 384 plus Q A4 over 64 minus C7 a over 2 plus C8. Okay. So, if you add these up, you get C8 equals minus 5 QA4 divided by 384 when you add these up. Okay. And if you subtract these, you get C7 equals 0. We get the relation for W as this. Multiplied by 1 over d11, and the relation for mx and my is d12 over d11 mx, and mxy is 0. And finally, we will also write down that u naught is equal to v naught is equal to 0, and nx is equal to ny is equal to nxy equals 0. So, this is the overall solution for which case? Case A. This is the overall solution for case A. So, what we have done in this till so far, how did we arrive at the solution for case A? First, we integrated the partial differential equations and we got expressions for nx, nxy, nxy, mx and all these things. Next, we implemented the condition specific to the symmetric laminate and cross ply laminate, and that gave us some relations for u, v and w, and also it also so it gave us some relations for u, v and w, and then we started implementing the boundary conditions, and the boundary condition for case A is that u, v, w and mx is 0 at x is equal to minus a over 2, and nx, nxy, w and mx they are 0 at x is equal to plus a over 2. So, once we implemented those 4 boundary conditions, these 8 boundary conditions, we were able to solve for 8 integration constants, and once we had that, we ended up with this solution that u is equal to 0, v is equal to 0, nx, ny, nxy is equal to 0, w naught is given by this expression and mx is given by another non-zero expression, and my is nothing but d12 over d11 times mx, and mxy is 0. So, this is the way to solve these differential equations, and we will again do more of this exercise so that we become comfortable and familiar with it. So, tomorrow we will develop the solution for case B, because we already have the solution up to this point, and now we will implement the boundary conditions for case B, and once again we will see what kind of solution emerges. So, that is all I wanted to discuss for today, and then tomorrow we will continue this discussion for case B. Till then, have a great day. Bye.